have Rob Dickinson with us, and we've got a very exciting session to sort of close things out, as you say, in this particular session, in this particular track. So without further ado, really, we are already past time, so we're going to go straight into it. Hello and welcome, everyone. Thank you for joining. This is going to be all about 200 is not always okay. It's an exciting title. It's a very interesting one, and we thought we'll close out this decision makers track with something really fun and exciting and obviously insightful. So Rob, maybe a quick introduction of yourself and then go straight into the session. So over to you.
Thank you. Yeah, and I think this goes really well with the last session. I really appreciated some of the points that Derek made around not all traffic is good. So this is some good curating here of the content. So 200 is not always okay, and what this means for metrics and observability is the title of this talk. And I am Rob Dickinson. I'm VP of Engineering at Graylog. I'm personally based in Boulder, Colorado, and I'm easy to find after this talk either by email or on LinkedIn. And I've been in the web and API monitoring and observability space for about 25 years now, starting in web, then moving into things like SOAP and all those things that we don't use anymore up to the modern APIs. So seen a lot of different cases around this. So the core idea here is that a great many observability tools and monitoring tools and even logging tools rely on HTTP response codes as an indicator of quality, as an indicator of what happened. And the basic idea there, as many of you probably already know, but just to kind of make sure we're clear on the problem statement, typically the convention that we expect here is that the response code 200 means that the request has succeeded, and that a response code above 400, so either in the 4XX range or the 5XX range, typically means that the request has failed. And that seems like a really simple way to organize your metrics, organize your indicators about what is the traffic that is good and what is the traffic that is not good. That seems like a really simple way to approach this and something that would be nicely, reliable. But the reality is that modern systems and even older systems, it's not really this simple. And the way that breaks down is that these 4XX, 5XX, the 400s and 500s codes, those can usually be trusted. So if you see one of those, that's typically a fairly reliable indicator that there was actually a problem, if not the exact class of the problem that needs to be addressed. The issue, though, is that 200s may or may not be okay. And so if we're assuming that 200s are always okay, then we definitely run the risk of undercounting threats and failures. And the amount of undercounting there can be pretty significant. Now, I realize that raises a lot of questions right off, because these are the questions that I had. You might legitimately be wondering, based on that problem statement, well, why is it that 200s aren't more reliable? Because the world would be a lot simpler if the 200s were actually reliable. But what are the factors that led to this kind of unreliability and not knowing what a 200 actually means? Is it a case where the web standards aren't being followed? Are the developers not doing their jobs? Has this ever been true? Is this something that just recently changed? Do APIs make this situation better or worse? And if we can't rely on 200s to say, okay, then how should we really be measuring this concept of response status? And I realize our time here today is short. Some of these are big ideas to crack open, but I think there's actually some pretty good conclusions that we can draw from this as far as how to move forward from a more informed posture. All right, so apologies for the eye chart here a little bit. but I wanted to start with the gospel according to RFC 9110. So if you go and look at the actual web standards for what does 200 actually mean, this is one of the earliest statements that you'll see there in that definition. The 200 status code indicates that the request has succeeded. And then the content that's returned in that 200 response depends on the request method. So you can already sense here, and if you read further than that, there is language that says things like, if it's a GET request, the response will be populated. If it's a delete request, there won't be a response typically because you just deleted the thing. So there's already, even just reading this part and then the paragraphs that come later, there's already some significant uncertainty here in what the 200 actually means. But there's actually even an earlier problem, which is this word success. It's actually not clearly defined. And that's a big problem. We think we know what success means, but as you really start to probe at that, and you think about the different cases that kind of align with this potential definition of success, it's actually not clear the more you look at it. And a certain amount of the intent here in the original standards was this idea that success is basically what the application defines as success. So this wasn't thought about from the perspective of, we're actually going to try to legislate what every application is going to do. We're going to say that every application potentially has its own unique concept of success. And as long as the client and the server agree on what success means, then it's all good from the perspective of the standard. So when you take a more literal reading of this language, though, you might expect that 200 means success in some kind of canonical way, the way a gigabyte means so many bytes, or with the other standards that we use that are actual units of measure. This is more of a statement about the contract between the client and the server than being a truly rigid definition that we can apply from an observability perspective. And if that doesn't make you deeply nervous, it should, right? Because in an organization of any size, you're going to have a lot of different APIs. And if you can't normalize this definition of success across them, you've got a significant problem now in terms of observability and really trying to understand what the quality of those interactions was. So let's unpack a little bit of how we got here. So one of the things that I was particularly curious about is kind of, how did this happen? How did we end up in this situation? We've known about this reality for a long time, but really, how did we get here? So where this idea really comes from is from this idea of custom error pages in the web world. And what's driving that is the observation that most browsers have a really poor user experience when it comes to unhandled errors. So if you get a 400 or a 500, it just says internal error. There's no real sense of what to do. The application isn't customizing that experience based on what the application knows. So a lot of times if you see an unhandled error in a browser, traditionally the user is just going to bounce to another site. It's a sign that they won't trust it. And there's lots of web studies from the early web that showed kind of the performance of errors in the browser versus performance of errors or retention rather of errors shown in the actual website versus in the browser. And that's where this idea of custom error pages came from. Let's not let the browser handle this. Let's let the application handle this. And so even as early as 1993, folks were starting to wrap their websites in custom error pages. to avoid this poor user experience on the browser side. We take this for granted now on the modern web, that there are going to be these custom error pages. They provide better context and they give direction about what to do next. But the tricky part from a monitoring perspective is that those custom error pages, even going back to 1993, they're actually served over the wire as 200s. So you're turning a 404 or a 500 or something else into that range into a 200 from the perspective of your logging and monitoring tools. And that's obviously going to skew things. But this is incredibly popular because of the user experience that it gives. So if you go to Disney, like one of my kids, and you can't find what you're looking for, you get, they plug Wreck-It Ralph, they stay on brand. They also give you tools or suggestions to help find what it is that you're looking for. So again, we're going to keep you in the site, right? But this is actually served as an okay, not going to show up to your monitoring tools automatically as a 404. And that's the whole point, right? We're masking these things out. You'll see a lot of this with 500 error pages. You'll see a 500 error page. The good ones make a good joke, or they try. They'll provide contact information. They may also provide an incident number or a case number that says, if you want to contact us, here's where we can look up what was just happening to you, and we'll be able to diagnose from there. And again, these are served as 200s. These are okay, right? No, these are absolutely not okay from a monitoring and a metrics perspective. And so we have to be able to tell the difference between that. And that's not really a new problem. Again, goes back to the early 90s. Where this comes into the web world is that public APIs, as we know them today, they're built on web standards. They're built on web frameworks. And just like with the websites that these APIs are replacing, that means developers can use the HTTP codes really as they see fit. Development still gets to define success in terms of those response codes as they want to. There's no canonical way to do that. And there are different schools of thought about what the convention should be. Even the frameworks that you use may have different default behaviors about how those response codes are used and what the appropriate client behavior is that goes along with that. On one side of the extreme, there's frameworks like GraphQL that literally only ever return 200s by convention. They really don't use response codes for error signaling at all. They choose to put all of that in the payloads. And as much as that is an extreme point of view to stake out, it's actually not violating the standard when you go back to the original language and the original intent. Another important thing to keep in mind here is that APIs may also use more response codes than just websites. Websites really do stick to 200s and 400, 404s and 500s, right? But with APIs, you may have 201s, you may have 204s. I mean, there's a lot more variability there in terms of what REST APIs will do and what they choose to signal. Some of them may all be 200, but you can't count on that. There's a lot more variegation in response codes when you're talking about APIs, because there's a lot more different cases than just rendering a web page. So what does this all end up to from a monitoring perspective? Well, it means the use of HTTP codes, you can't really expect it to be perfectly consistent. It's difficult to make it consistent. And the misuse, if you say that's wrong, we want to do something different, that misuse tends to be difficult to correct as well, because it's not just changing the behavior of the server, it's changing the logic on all of the clients. that interpret those HTTP codes, because you're changing the contract between the client and the server. So from a practical perspective, you can't really expect the response codes to be perfectly consistent. So instead, your monitoring and observability stack is going to have to help you in doing that mapping. What that translates to, unfortunately, again, there's a lot of these cases where we can undercount failures, and we can have 200s that are not okay. And believe me, I don't like that idea. It doesn't make me happy to announce that as something that looks like a permanent condition as far as the web as we know it. But I think this is accurate about the state of the market and where we're going to be in the future. So let me give you a couple simple examples, and then beyond that, I think you can imagine more of the variations about some of these cases where you can have a 200, but really the outcome or the success, as many people might think of it, is not good, right? Is not always okay. So one of the examples, and this is something that we see all the time, are 200 responses where the actual backend processing has failed. And this could be in the API that you're talking about, or in an upstream API that it's dependent on, right? But what actually comes back to the API consumer is not a valid response. It's some kind of stack trace and something that wasn't actually grabbed by some kind of error handler, right, to return a better response. This is something, again, you just see all the time, because these are classic ways that those backing applications can fail. In this case, we have a made up application called Coinbroker. We've tried to do a purchase without providing any information. And obviously there's parameter checking that's missing here. And so the whole thing has failed. And so it's not just a failure, but it's also leaking security details about the backend system. If this was an attacker doing this on purpose, you're really giving them some very good information about how to attack the system from here. And yet, from a protocol perspective, it says 200 okay. Is that okay? No, that's really not okay. Whether it was a legitimate user or an attacker, it was definitely not okay. And you definitely want to know the difference between the context in that. Now you can say, well, gosh, I would just tell my developers to never do that. And that's fair. But these apps will break this way, despite what all your developers do. When one of these apps breaks, this is what it looks like. A lot of times from the consumer perspective, that logic that you're counting on is maybe part of the logic that failed and why this wasn't marked to 500. That can happen too. Another classic example where 200 is not okay is where there's a significant breakdown of communication at the application layer versus the network layer. So from a network perspective, it's okay because we got the request, we responded, that went back to it was properly interpreted, but that's where it breaks down. So in this case, we tried to do a get for a quote, and because we didn't provide any other information in the quote, we actually got back invalid JSON. So there's supposed to be a string right here. And obviously there was some conditional logic here, and it didn't print out the token. And this is actually and again, it says 200 from a protocol perspective. And you might even say, well, it is okay. I mean, I did actually give you back a quote, right? But there's no client that's going to be able to parse this without getting an error from their JSON parser. They may have to retry it. I mean, it's gonna cause downstream damage if you're ever serving payloads like this that are malformed. And there's all kinds of variations of this. It could be a comma in the wrong place. It could be a quote that's missing. It could be an unescaped character. Like think about all those places, right? Because you're generating these responses dynamically. So of course that can break down in all kinds of different ways. And it may not be doing that 50% of the time. It might be doing that 1% of the time. But that 1% of the time is actually affecting, real users. Is that okay? No, that's not okay. Here's another more of a security example. In this case, this is an attacker that's requesting a restricted file. So a lot of these API servers are actually web servers themselves. So if I do something like asking for the .env file and the API actually gives me back the .env file, that might say okay from a protocol perspective because that's what the API was dumb enough to do, right? But that is absolutely not okay from a security perspective. That is a very serious response. And you need to know what data was leaked. You need to know what are the keys that need to be changed and things like that to go with those attacks. So 200, absolutely not okay. And then of course, there's things like GraphQL where it's just 200 by convention. If there is an error, like I'm showing in this case, the error is actually encoded in the response by convention. And that's not unique to GraphQL, by the way. There's a lot of custom applications and in-house applications that use that pattern. They just didn't want a signal based on HTTP codes. So how do we get to more of a place of full understanding of response status? It's fine to start with response codes. Any data you have, any monitoring you have is better than no monitoring at all. So if you don't have any metrics today and you want to start with metrics based on response codes, that's still a huge crawl in the right direction. What we kind of advocate is creating your own concept of response status and use that. And so the places where you'd be tempted to use response code, use something like response status instead, where you get to bring in what success really means and overlay that the way that the standard expected. You can then get to more of a run stage if you're calculating that response status based on the full request and response together. And then if you can mix that with also threat intelligence and knowledge about what the API specs are actually doing, you can actually get to a concept of response status that is truly reliable and independent of some of these ways that response codes can be prone to being undercounting threats and failures. And if you want to jump to the end of that process, we'd love to talk to you about that. That's one of the things that we're doing with Graylog API security. We're out to make that easy. We've got an offer going where your first node is permanently free to use the software for discovery and for threat monitoring, and for also things like scoring on response status. And we just want to help your blue team, help you pump up your defense, and to also understand the data that's flowing through your Tyke infrastructure.
Wonderful.
Thank you.
Thank you so much, Rob. That has been incredibly insightful. I think we can all say it together. 200 is not always okay. But having said that, there is, like you mentioned, there is a bit of a nuance to that where it could still be a very good starting point. It does tell you something. It doesn't give you the full picture of everything that's going on, and that's okay. I think it's more to do with the awareness and therefore being able to strategize around it better to be able to sort of complement each other. I think we were having this discussion with Agatha in a previous session where we talked about GraphQL and OpenTelemetry and what sort of could go wrong with GraphQL and where OpenTelemetry could help. And we sort of saw a very similar approach there where it gives you certain pieces of information, but there is still a few things that you need to cater for. And OpenTelemetry solves most of them, but there are still certain things that you need to sort of address over there. So yeah, that's really, really insightful. Thank you so much. This has been an incredible session. And I don't know if anybody has any particular questions before we fly on to our final session of the day. But if not, this has been an incredible session. Rob, thank you so much for sharing your insights into this world of status codes and what works and what doesn't work. And thank you so much for being part of this. Thank you, everyone, for listening as well. And we'll see everyone in the closing remarks and closing ceremony in about 3 minutes time. So thank you, everyone. It's been a pleasure. Thank you, Rob. See you in the next
Awesome.
session.
Thank you.
Cheers. Bye.